So, last class we looked at the effect of using a cane when you have weak hip abductors and how using the cane reduces the load on the opposite side. Okay. So, you use a cane to compensate for either pain or weak hip abductors on the other side. Okay. So, we saw the analysis that led to that. I just wanted to mention in the problem that we had last time, there was one the answers that I gave you, they would be for, so they assume that this distance is very small. So, basically the joint, where the joint forces act, the moment of Fm cos theta was negligible, because there was one quantity that was missing. So, it basically assumes that it almost passes through the joint, that this head it's like this almost okay. So, instead of having this extreme inclination, it is almost as if Fm, Fm cos theta does not cause a moment about the joint. So, the values that I gave, the answers that I gave you would be valid for this, okay. Moment of Fm negligible about the hip. If you can assume some distance for that and compute it, you will just get answers that are slightly different from what I gave you. Okay. So, that was the so we looked at the two cases. One, you can see that this was the one with the cane, and basically we saw that it is too extreme. So, if this is the cane on the other side, and this is just single stance where you do not have a supporting cane on the other side. So, these are the two things that we compared last time, and we found that the loads on the hip reduce considerably when you use a cane, even though the cane takes only a small portion of the overall body weight. Okay. Here I think we assume the entire body weight is acting on this leg. Here we had 5 by 6 W and W by 6. Okay. But here this is along the direction of the net W. Here the body weight acts somewhere in the middle, the foot is displaced. Okay. So, the overall body weight acts somewhere here and the foot is displaced. Okay. So, you see that just as using the cane as a support reduces that. So, let us look at the case where you are carrying a load. Okay. If you are carrying a load on one side, now this is going to be the reverse of supporting using a cane. Okay. So, here if you have, let us call this W dash, where W dash equal to, so if I take the free body diagram in single stance of this side, the leg that is suspended and the whole body, then this W dash is basically the whole body weight minus the weight of the supporting leg. This is the supporting leg, this leg. I am removing that from the, I am removing that for the free body diagram, and then I have the muscle force which is acting here. The what muscle am I talking about here? The hip abductors. Hip abductors acting to Fm for hip abductors. The primary hip abductor is your gluteus medius. So, again this becomes a, so if this is my joint at which, then it becomes a 3. So, if I look at, I have WL. Okay. So, WL and W dash together I can find, if I did not have a WL. Okay. Let us say if WL is equal to 0, okay, then I have, this is a 3/4 system, and essentially this joint force also has to pass through that point. Okay. So, if WL is 0, I have this. So, let us say this makes some angle phi, the joint force makes some angle phi with the horizontal from this geometry. I have WL, I have FM, and then this also I know where J is the location. So, this would be J making some angle phi, okay, and then I can just use sigma f x equal to 0, because this is basically using sigma m equal to 0. Now, if I carry a load, so J and Fm are not parallel, they are not parallel. So, here I have this angle theta. So, I can find out in this case. So, if Fm is acting at an angle, let us say theta to the horizontal. Okay. So, I have, I can draw this as theta, then I have W dash, and then I have at some angle phi. So, Fm cos theta equal to J cos phi, and Fm sin theta plus W dash equal to J sin phi. Fm equal to W dash cos phi by cos theta sin phi minus sin theta cos phi, if I solve for Fm from there. Now, if I carry a load WL, okay, then essentially that is going to shift. So, instead of W dash here, it is going to shift slightly away from the midline. Okay. So, if there is a, if WL is not equal to 0, then I can sum these two parallel forces, and I can say that the new CG lies somewhere between these two, right, which would be away from, still more away from the midline, where I have the load only on one side. So, if I have that, then essentially what is going to happen, the moment about the hip is going to increase. So, now what is my phi going to be? Is it going to be less or more than what I have now? From this, can you tell? Now, instead of W dash, this has shifted slightly. Okay. If WL is not equal to 0, I have this equal to W, let us call it W double dash equal to W minus WL, sorry, leg plus WL, okay, and it would act slightly to, it would act somewhere here, okay, it will be larger and slightly shifted from the midline. So, now if I intersect these two, okay, Fm and this. Now, my j is still here. So, that will be my new the direction of the new j dash. Fm also the magnitude will change, it is not going to be the same. So, I will have, but it will act along the same line. Okay, I have Fm. So, now j dash is going to be more, okay, and this angle phi will also be smaller than what you had. So, you can see here, if I take this as w dash cos phi by sine of phi minus theta. Okay. In the second case, my phi dash will actually be smaller than phi. Okay. So, that makes this the denominator smaller, which increases the muscle force. Okay. The overall effect will be because w dash has also increased now. The numerator has increased. So, that any offset in the cos phi will not compensate for the increase in the w dash. Okay. So, overall, so when you carry a load, this is the reverse effect of using a cane. The load on the opposite side, on the side opposite to where you are carrying it, you are going to see more loads on the hip to balance this. So, what do we normally do when we carry a weight on one side? So, if I during my right leg single stance, I will tend to lean over to the side opposite to the side where I am carrying the load, right. So, what am I trying to do? I am trying to move the net, I am trying to move the CG closer to the midline, so that I can reduce the loading on my hip. Okay. Let me just m dash will be w double dash cos phi dash by phi dash w double dash cos phi dash by sine of theta dash minus phi dash minus theta. Okay. So, so it increases the loads on the single stance side, carrying a load on one side single stance. Now, if I distribute the loads on either side, then my net, so if I say I am carrying WL on either side, okay, let us just say the same WL, so let me call it WL by 2. Instead of carrying it on one side, I distribute it equally. This is W dash, which is equal to W of the body minus weight of the leg. Okay. So, the net is higher, I have W double dash equal to W dash plus WL, okay. But this time, because it is equally distributed, it will be closer to the midline than in the previous case. Okay. Here you will have the, so during single stance, it will reduce the, it will still be higher because you are carrying a load, okay. But when it is equally distributed, then this is closer to the midline than when carrying on one side. And therefore, you will even though the hip loads are higher, it will be lower than this previous case. So, the better way of carrying a load is to distribute it equally on both sides. Okay. So, you are not loading one side. So, any time you bring loads closer to the midline of the body, it helps to reduce the musculoskeletal forces. We saw that with the arm. Okay. Any time you reduce the moment arm, body weight is usually your external load, body weight or the loads that you carry. Any time you bring it closer, you reduce the moment arm about the joint, you are going to have less damage done, okay, to reduce the musculoskeletal loads. So, when carrying, in order to do that, what you do is, when you carry a load on one side, we lean towards the other side. This brings the CG of the upper body and loads being carried of the body and reduces the from the distal hip joint. I should say farther hip joint, since distal has a specific meaning. So, people with weak abductor muscles, hip abductor muscles and or painful hip joints, how do they walk? They lean towards the weaker side. So, as they are walking, you can, if you observe them, you will see that they have like a swaying gait like that. Each time when they are getting on single support, they are going to lean more towards that side. Okay. So, they have this, it is called abductor gait. So, this helps them to reduce the loading on the hip joint on the weaker side. Okay. So, okay, let me let us say they lean towards the loading side, that is probably a better way of saying it. So, if I have hip say left side weak hip abductors, I lean towards the right. So, the loading side towards the, because single stance on the right side. So, weak left side lean towards right during right single stance and vice versa. Okay. So, if I have weak on both sides, okay, then I lean to the right, then when I am loading the left I lean towards the left. Wait a minute, did I? Okay, no, wait. Weak, sorry, they lean towards the opposite side, right, from the loading side. Hold on, just a minute. I have they lean towards
the opposite side, but the loading side itself is the weaker joint here, right?
Not necessary, we can put the load in the weaker side.
See, when you are standing, it is equal on both sides. We are talking about the single stance case, okay, where you are putting all the loading on one side. Okay. So, you are loading one side. Here in this case, it is the right leg, for instance. Okay. Now, when all the loading is on this side, okay, I need to bring this line closer to that side to reduce, because this is the stabilization that is happening. Okay. This is where my abductor muscles have to stabilize the joint, because I am supporting, see, I have this body weight which is creating a moment about this joint. Okay. I need to reduce that moment arm. So, I am leaning more towards the loading side. This is the muscle, no, this is the muscle I am trying to use. Okay. So, it is towards the loading side. And we are talking about in single stance, where all the body weight is on one side. And vice versa. So, if I have a weak right side, then when I am on left side single stance, I try to lean more towards that side, so as to reduce the momentum. And to correct the abductor gait, you would hold the cane in the hand opposite the weak side. Of course, if you have on both sides, then it becomes a problem. Okay, but typically if you have an injury on one side, then holding a cane helps, because otherwise you might have to use something like a walker to do that. Okay. So, if it is a problem on one side, a cane on the side opposite to the affected side can help you, but if not, if the problem is on both sides, then because the other side will keep getting loaded anyway. So, the cane alone will not help. Okay.